the nighttime side of Earth is where you see stars. I hope you agree with me. When it's over here on this side, these people are experiencing daylight. They don't see the stars unless there's an eclipse. But over here, I look out into the vastness of deep space and I see stars. Well, in 6 months, where's this ball Earth going to be? Over here. Where's the nighttime side of this Earth going to be? It's going to be facing a different direction. And this animation shows you that. And I pause it along the way. But here's the Earth spinning, tilted on its axis. We're looking this direction, okay, at these stars. 3 months, I would be looking at different constellations entirely almost. Okay, we're now facing this direction. But 6 months, I would be on the other side of the sun looking at stars that you and I have never seen. They're on the opposite side of the sun. I looked at these stars every night, and it was quite game changing for me in my belief because I wanted to prove all things and go out there and look and make observations. And I was seeing the same constellations for an entire year. They did shift with the sun. When the sun went south for the winter, the sun kind of moved across the sky. It went in a southern direction, and its circular path changed on the earth, and that's what's responsible for our seasons. And when it did that, the stars and everything seemed to move with it. I thought that was really, really cool. A really cool observation. And you can make this observation yourself. It's very, very simple. Not trying to deceive you in any way, and could be wrong about some points. But again, it's humble enough to understand that we've probably been lied to, and no, not every single scientist is in on it. It's not it's not like that at all. They're all deceived, and their really smart minds are just repeating everything they're told, and they all just want to get published. It's not about being right. It's about looking smart nowadays. And if you question what you're told, you can get in big trouble. And many people have. So here's the sun, really large looking. I know this is exaggerated because of the glare, but watch the size change as this thing goes down. Very tiny. You pause that right there. Look at that sun. Very, very tiny. There is hardly any moisture in the air, very dry climate. That's what you will see in those areas. You can go somewhere where there's moisture near the ocean. Sometimes you watch the sun go down over the ocean and it looks gigantic. Okay, it'll look bigger than some of the nearby structures you see. So it's very, very drastic differences depending on where you're at. The sun is not shrinking and growing and all of those weird things. It's just the appearance of changing sizes. It's really just getting further away from you. The last thing we're going to look at is how far the Earth is said to move around the sun on any given day. And it's quite mind-blowing because I'm a visual person. I like to make visuals and see things that I can actually look at and get a quick understanding of what I'm being taught. Not really good at just seeing something written on a page or hearing things. I like to see it. So here is these little blue circles here, or blue dots, are actually the Earth. Just shrunk it down. I kind of shrunk the Earth down so that it would fit on this page. But how many Earth distances the Earth would travel in a single day, it would take all of these Earths, because they say we're going the 66,600 miles per hour around the sun, and that is a total of 201.8 Earth distances per day, or if you want to do that in miles, 1,598,400 miles. So quite the journey for just one day. So I put out a video of this image of Earth from space, and it was taken from the Titan, from Titan, when I think the spacecraft was called the Huygens spacecraft, but they were going to Titan. And what happened is they sent us some footage of the Earth, as you can see in this little dot here in the thumbnail I have, and the moon, and they're passing in front of the Earth, and I will let you see that. So here's the Earth right here. This little dot here is the moon, and if I hit play, you'll see it move across the sun. Here it goes, trucking along, Earth. And my thought was, if the Earth moves that far on a given day, it's almost going to make it around the sun pretty fast. That was my thought when I first saw this, and I thought this had to have been over a period of weeks, and the moon would be going around the Earth during that time, but instead it was keeping its equal distance as it went along. I may have been wrong if you're basing it on the perspective and the fact that the Earth moves this far per day. You may see something like that. So I might have been wrong on that aspect of it. And I was always curious that if we're going around this sun, because I've broken it down here on a pie chart, per day, you would move as much as this red filled in part of the pie chart. Not a large movement, and that's why I was thinking that footage was taking place over a large period of time. But this Earth is not to scale. It would be a little tiny dot, and it would move several or a couple hundred times more than its own diameter within this red line here. So it's really, really challenging to scale things down with this model they give us, and that's why it's easier for us to be deceived, because they give us these large numbers that make it really hard for us to create accurate visuals on any scale. Now, one thing that I want all of you to do, if you're looking into this for the first time, please don't take our word for anything. Look into this stuff yourself. And here's something I put together when I was first into this movement, I guess about 6 or 7 months into it, and I had been making my own observations, basing them on the globe model, and thinking that if it's true, I should see what I would see if I was on a ball going around a giant sun. And I wasn't seeing that.